Now we'll look for the next chapter, that is design of gearbox for machine tool applications. Now the contents are that going to be covers are design of gearbox for machine tool application, that is for maximum 3 stage and 12 speed. Means 12 speed means it will become 6 speed gearbox, 9 speed gearbox and 12 speed gearbox, and that will be limited to maximum 3 stages. Now next is we'll see the requirement of gearbox, that is determination of variable speed, graphical representation of speeds, structure diagrams, ray diagrams, selection of optimum structure diagram, calculation of number of teeth on each gear, layout of gearbox. These are the content. Now we'll see the gear trains. Gear trains act as a speed reducer or speed increaser. The application of gear trains are back gear mechanism of lathe machine headstock, screw cutting in lathe machines, automobile gearbox. Now gearbox are classified. Gearbox are classified as single stage gearbox and multi-stage gearbox. Now we'll see the design consideration for multi-stage gearbox. So first consideration, the optimum number of speed step with incremental between 10 to 15% of total speed range. Okay, this is the first design consideration, means your step speed is 10 to 15% of total speed range, means n max. Now next design consideration is the gearbox or multi-stage gearbox can be, that is speed can be changed without stopping the prime mover, that is IC engine or electric motors. Next, that is one gear in engagement at a time, means see here examples. There are two stage gearbox. This is first input or the first, this is the first pair of gear, second pair of gear, but as per design consideration only one gear must be engagement at a time, so this is the not. Now next design consideration is use of minimum number of possible parts. This is the next consideration. Now the next consideration is ergonomically design and centralized control unit. The entire drive unit located inside the machine tools. These are the basic consideration for multi-stage gearbox design. That is, first one is a optimum speed with step speed of incremental 10 to 15% of total speed range. That speed change occurs without stopping the prime mover. Third one is a one gear in engagement at a time. Use of minimum possible parts, ergonomically designed and centralized control unit, and entire drive unit located inside the machine tools. Now we will see the location of gearbox. That is, gearbox is connect the machine tool and prime movers by using shafts and couplings. Now gearbox are used to change the torque and speed or to change the orientation of device or the machines. Now next we will see the design of gearbox for machine tool applications. That is, the machining operation should be conducted at a specific value of cutting parameter, that is speed, feed, depth of cut, etc., that ensure the minimum cost per components. Now various law of speed regulations. In a step regulation of speed, different values of RPMs are available on the machine tools between minimum speed N1 to maximum speed N max. To achieve the different speed, there are different laws, that is arithmetic progressions, geometric progressions, harmonic progression and logarithmic progressions. These are the four basic law. Now we will see the first, that is arithmetic progression. That is difference between adjacent RPM value with constants, means assume N1 is a minimum speed, that is input speed, N2 will be N1 plus A, where A is a arithmetic progression ratio. Similarly, N3 will be N2 plus A, that is N1 plus 2A. By putting N2 here, you will get N1 plus 2A, that is N, that is generalized formula. Nz is equal to N1 plus Z minus 1 into A. So where A is a arithmetic common difference, so A will be A is equal to N max minus N min upon Z minus 1, where Z is number of steps, means 12 speed gearbox, 9 speed gearbox, 6 speed gearbox, like this. So Z is 12, 6, 9. Now next is a geometric progression. Next speed regulation law is geometric progression, that is ratio of two successive spindle speed is constant, means assume N1 is a input speed or minimum speed, N2 will be N2 by N1 is 5, 5 is a geometric progression constant. So N3 by N2 become 5 and N3 will be in terms of N1, N1 into 5 square. So generalized formula will be N max upon N min is equal to 5 raised to Z minus 1, where Z is number of speed steps, that is 12 speed gearbox, 12 speed gearbox, 6 speed gearbox, 9 speed gearbox, where 5 is a geometric progression ratio. There is another, that is 5 will be calculated, 5 is equal to N max by N min raised to 1 upon Z minus 1. Example, take if N1 is 30 rpm and N12 or 12 speed gearbox, the output rpm will be 375 rpm, so Z become 12. So 5 is equal to N12 by N1 raised to 1 upon Z minus 1, so 375 upon 30, 1 upon raised to 1 upon 12 minus 1, so 5 become 1.26. So this is a generalized formula, that is N max upon N min upon 1 minus Z minus 1. So during solving the problem we need this formula. So another formula to calculate the phi, that is geometric progression ratio, phi is equal to, that is series root of 10. So you will be given a different series, you have to put here and calculate the root of 10 with a series. Now next geometric progression law is, next law is harmonic progressions. Harmonic progression, that is diameter range is served by each rpm of progression is equal, that is delta change in diameter is equal to dx up minus dx plus 1 is constant. So diameter is inversely proportional to the speed, so 1 upon n max minus 1 upon nx plus 1 is constant. So nx plus c is equal to nx 1 minus c into nx, so n2 become n1 upon 1 minus c into n1. Similarly n3 become n2 upon 1 minus c n2. So put calculate or put the n2 value in terms, put the n2 from here, so n1 minus 1 minus c, again n2 here n1. So we will get a generalized formula, n3 is equal to n1 1 minus 2c n1. So generalized formula is nz is equal to n1 1 minus z minus 1 into c into n1. This is the harmonic progression. Okay, in exam or they will ask the find the different speed using harmonic progression, logarithmic geometric progression and arithmetic progression. Now next is a last is logarithmic progression, that is speed step is variation between two adjacent rpm is a logarithmic. Okay, we saw the difference law, that is first one is a arithmetic progression, here. Second one is a geometric progression, third one is a harmonic progression, and fourth one is a logarithmic progression. Now the theory question is, what are the advantage of arithmetic progression, what are the disadvantage and advantage of geometric progression. Now next, that is the commonly the geometric progression is widely used in the industries. The selection of geometric progression ratio phi in multi-speed gearbox. The recommended values, that is if heavy duty machine tools, then phi is equal to 1.1 1 to 5, that is geometric progression ratio, or it is called as a series 20. Second is a large to medium size machine tool, that is phi is equal to 1.26 or series 10. Similarly, medium size phi is 1.41 or series 20 by 3. Medium to small size phi is 1.58 or series 5. That is, if we know the formula, that is phi is equal to series root of 10. If series is 10 given, then phi is equal to 10th root of 10. If series 20 is given, then 20th root of 10. Or series 20 by 3 is given, then phi is equal to 20 by 3 root of 10th. These are the values. Okay, these are the values are given in PSG also. We'll see that. Now next we'll see the structure diagram, structure formula and their analysis. Now the transmission range Ig is equal to I max upon I min, that is maximum reduction upon minimum reduction. Now the structural formula, it is the mathematical expression which gives the distribution of speed step in each stage and number of spindle speed steps by which two adjacent speed values of the stage varies. The structural formulas are written in terms of Z is equal to P1 x1, P2 x2, P3 x3, where P1 is a number of speed step in a transmission group, X is a characteristic of transmission group, and Z is number of speed steps. Now if 12 speed, then Z is 12. So here suppose Z's are speed step, that is N1, N2, N3 up to Nz RPM, then N2 by N1, N3 by N2, N4 by N3, N5 by N4. These are the K, that is geometric progression. So K is equal to 5 raised to X. Where X denote the number of steps, that is this X. K is equal to 5 raised to X. This X denote the number of steps in the spindle RPM by which two RPM values are separated. Now the transmission group, that is P into X, is known as transmission group. So Z is equal to P1 x1, P2 x2 and P3 x2, that is one transmission group, another transmission group and next transmission group, where P1, P2, P3 are factor of Z, that is number of speed step. We'll see in the example. Now if number of speed steps are 8, then factor of 8s are 2, 2, 2. So P1 is 2, P2 is 2, P3 is 2. So Z is equal to 2 x1, 2 x2, 2 x3. Now what are the values of x1, x2, x3? So x1 is 1, that is input, always x1 is 1, that is input for the gearbox. x2 is number of speed step corresponding to the x1. So see, this is the x1 is 1. Now x2 will be the number of speed steps corresponding to x1, that is this 2. x2 become 2 in this case. And x3 is a multiplication of number of speed step corresponding to x1 and x2. These are the speed steps. So x3 will be corresponding to x2, speed step is 2 and x1 is 2. So multiplication of this will become x3, that is 2 into 2, 4. Now number of, we'll see during solving the problem actual what is how the transmission structure formula is written. Now if number of speed steps are 9, then factor is 3 into 3. So P1 is 3, P2 is 3. Similarly Z is equal to 3 x1, 3 x2. Again x1 is 1 always and x2 will be the factor corresponding to the or speed step corresponding to the x1. So x1 is 3, so this x2 become 3. If number of speed steps are 6, now next factor of 6 are 2 and 3. So P1 is equal either become 2 and P2 become 3, or P1 become 3 and P2 become 2. There are two structural formulae will be formed here, that is 2x1, 3x2, 3x1, 2x2. Now here x1 will be always 1 and x2 is factor or speed steps corresponding to the x1 is 2, so x2 become 2. Or second formula is when Z is equal to 3x1, 2x2. Now x1 is always 1, so 3 x2 will be this speed step corresponding to x1, the speed step corresponding to x1 is 3, so x2 become 3. Now in case of number of speed step is 12, the factors are 2 into 2 into 3, that is 2 into 2 is 4, 4 into 3 is 12. So there are 3 p's and 3 x, that is p1 p2 p3 x1 x2 x3. This can be arranged into 6 ways. So that is z is equal to p1 x1 p2 x2 p3 x3. This can be arranged into 6 ways. Okay, we'll see this during solving the problem. Just remember that that is structural formula. Z is equal to p1 x1 p2 x2 and p3 x3, where p1 p2 p3 are the factor of z, that is number of speed step, and x1 is always 1, that is input 1. x2 will be number of speed step corresponding to x1, that is this p1, this become x2 p2. So in this case, okay, not a p1 always, so the factor corresponding to x1 will become x2, and x3 is a multiplication of speed step corresponding to x2 and x1. These are the speed step corresponding to x1 and x2, so multiplication of these two will become x3. Now point to be considered for structural formula and structural diagram. For feasibility of structural diagram or structural formula, so x1 is a less than x2 and these both are less than the x3. This is the first feasibility of the structural formula. Next feasibility is phi raised to b is less than or equal to 8, where b is a distance between the two extreme line originating from the single node. Okay, we'll solve this b after drawing the structural diagram. Now next is structural formula. Take the, that is z is equal to 2 into, that is this is the 12 speed gearbox, that is 2 3 2. These are the p1 p2 p3. Now and these are the x1 x2 x3. So x1 is always 1, x2 will be the speed step corresponding to the x1, that is 2, this here 2, and x3 will be the product of speed step corresponding to x2, this 3, and x1, this 2, that is 3 into 2 6. Now the outer, that is p1, this indicated the line originating. Okay, these are the importance while drawing the structural diagram. See, this is the, this 2 indicated the number of line originating from the initial node. Okay, we'll see during example. Now this bracket figure indicates the distance between two end of the final nodes or the distance between the two nodes. Next is vertical lines are the shaft of the gearbox. While drawing the structural diagram, the vertical lines indicate the shafts of the gearbox. The horizontal lines are the number of steps, that is z. So see, here is one example of structural diagram. So here 2 into 1, 3 into 2, and these are the vertical lines 1 2 3 4. So vertical lines indicated the shaft s1 s2 s3 and s4, and these are the horizontal lines indicate the number of steps. So see here, structural formula 2 into 1 3 into 2. So from a single point, two lines are originating which are separated by 2. This bracket figure indicated the distance separated by two nodes. Similarly here, from this node 3 lines are originating 1 2 3, but these 3 lines are separated by distance 2. So these are the two distance, these are separated by 2. Similarly from here 3 lines 1 2 3 which are separated by distance again 2. This is the structural diagram. Okay, we'll see in the details while solving the problem. Now next is a ray diagram and speed chart. That is, structural diagram gives the information about number of shaft in the speed box, that is vertical lines, number of gear on each shaft, that is this figure, bracket figures. This outside figure gives the number of gears on each shaft. This means first stage में 2 gears, 3 gears and 2 gears. And third is a transmission range and characteristics of each groups. Now what is a ray diagram? Ray diagram displays the exact location of speed, and then ray diagram is used for the calculation of gear ratio and number of teeth on the gears. So the input speed of the gearbox, that is log ni is equal to log n plus log phi upon 2. Remember this formula. Okay, this formula is important while solving the problem. The condition to be considered while plotting the ray diagram, that is n max upon n input less than or equal to 2, or n min is greater than or equal to 1 by 4, that is 0.25. This is your ray diagram. Now we will see the steps while solving the problem. There are 8 steps. First is a calculate the range ratio and speed step, first step. Second step is calculate the number of stage and number of shafts. Third step is a structural formula. Fourth step is structural diagram. Fifth step optimum structural diagram. After that, step number 6 is a ray diagram. Step number 7 is a gearing diagram, and step number 8 is a number of teeth on gear. Now next we will solve the one problem.